Now, scientific notation is a way to represent really, really big numbers or really, really small numbers in a nice compact way. And it also gives you the benefit of being able to do calculations without doing a lot of counting of zeros and things. And so when you have a large number like 210,000, what you want to do is you want to put this into a form where you have that, the actual numbers, the 2.1, and then times some power of 10. And so we see that 100,000 is actually 10 to the fifth, right? It has 10 zeros behind it. And so this is scientific notation, is when you see it in this form. So your calculators, when they get into a really large or really small number, automatically go into this. Oftentimes in scientific calculations you use this exclusively, no matter what size of number that you're dealing with, unless of course you have a very small integer. So we go over 5 places. You don't have to write that second part. You can just say, okay, I'm going to go over 5 places, and that becomes my exponent. Okay, so then that first part, the 2.1, we always want something in front of the decimal, 1 to 9. You don't put a 0.1 or anything like that. It always has to be a number between 1 and 9. And you make an adjustment if you end up with something outside of that. So we'll see that in a couple examples coming up. Okay, so 3,700, that's going to be 3.7, and then we have 3 decimals that we're moving to the left, and so that's going to be 3.7 times 10 to the third. Now to go backwards, basically what you do is you start writing the number, that 214, write it without a decimal, and then start where the decimal is, count 6 places off of that, and you can see here we only have 4 actual zeros, but we are 6 decimal places away from that 2.14, and so we have the equivalent there. All right, so here's a couple. I want you to put the first one in scientific notation, second one I want you to put in just a standard notation. Okay, so what'd you get? First one? Yes.
3.6 times 10 to the 6th.
Mm-hmm. And the second one, I kind of threw that one out there, is 93 million. Does 93 million ring a bell? It's a number that is something that you see around. Not a lot, and probably not in your circles, but 93 million is the number of miles we are from the sun.
Oh.
Okay? It takes 8 minutes for light to get from the sun. I bet you couldn't live today without knowing that. That's going to come up sometime today. All right, so small numbers. We do it with small numbers as well, except now we're going to be using negative exponents. And so something like this, we're going to move over 3 decimal places, and so that's going to be 3.4 times 10 to the minus 3. So where this comes from is if we have 3.4 times 1 over 1,000 like that, that's where this comes from, where you have 3.4 times 1 over 10 to the third. Okay, and so then remember what happens when you have an exponent in the denominator and you want to bring it to the numerator, you change the sign of the exponent, and so that becomes then 3.4 times 10 to the minus third. All right, and then we can go back the other way, where we start out writing the 242, and I guess I forgot the 2 on the very end of that, huh? Like that. And so we count over 7 decimals. All right, so here's one for you to try. Write these out in the opposite notation. So the first one put in just a regular notation, the second one put in scientific notation. Now this one, of course, it's a little harder because you're just not adding zeros. You have to, put leading zeros, and it's a question of how many to put. One of the strategies that you can use is just write a mess of them in the front, count them off, and if you don't have enough, of course, add a few more. But write enough so you can count it off and then erase all the ones before that. So in something like this, you start out with 86, and you put a mess of zeros in front of it, count them over, and you should get something like that. And then, of course, the 0.00031. What you can often do with converting it in is, you see I have 3 zeros between the decimal point and the first number, so you just take another number, so it's -4 is how you're moving it, because you want that 3 on the left side of the decimal, and so you get it like that. Okay? So you take any science course, especially chemistry, but perhaps also physics, you'll see this notation pretty commonly. So, computations with scientific notation actually make the computation a lot easier than if you were to take these big and small numbers and multiply and divide them apart. So remember, when we have the same base, we're adding exponents. And so this is going to be the key to working with scientific notation, is that whenever we have some number times 10 to the whatever power, we're going to be adding the exponents on the 10 part and then doing the regular multiplication on the first part, the numbers. So another example of just adding exponents. So if we have a number like 1.4 times 10 to the third times 1.1 times 10 to the minus fifth, what we're going to do is multiply 1.4 times 1.1, and we get 1.54, and then we add 3 and -5, and we get -2. So there's our answer there. All right, another example. If we have 3.6 times 10 to the minus 12th times 4 times 10 to the 8th. Now this is something that frequently happens. We'll get 14.4 times 10 to the minus 4th. But there's something wrong with this one, because we have 14.4, and what we really want is 1.44. So what you do is you work it out like this, keep track of the exponents of 10, and then we make an adjustment, and we say 1.44, or 14.4 is actually 1.44 times 10 to the first, so we add that 1 to the -4, and we get 10 to the -3. Now you don't have to write out this intermediate step here, this middle one. Oftentimes you can do that in your head. But if it's at all confusing to you, or if with the negative exponents it seems a little shaky or so, by all means do it, because then it becomes a simpler problem. You know, it's easy to put 14.4 into the scientific notation 1.44 times 10 to the first, and then you remember do you add 1 or do you subtract 1 from -4? And of course here we're adding 1, so we get 1 plus -4 is -3. And we can do division as well. So in this case, what we're going to do is we're going to take 7.2 divided by 2, and that'll be, and then times 10 to the 4 minus -3. So we get 3.6 times 10 to the 7th. So we're kind of doing two calculations here. One is on the number, and the other one is on the power of 10. And we make adjustments whenever we need to. Okay, so another example. We have 1.2 times 10 to the -5th times 3 times 10 to the 3rd. So we take our 1.2 divided by 3, and then we resolve the issue of taking the exponents of 10. So it's going to be -5, and then since the 10 to the 3rd is in the denominator, it's going to be -5 minus 3 is -8. And then when we take 1.2 divided by 3, we're going to find that that's 0.4 times 10 to the 8th. Now here we have to make an adjustment as well. And so since we're moving the decimal to the right, we have to subtract a decimal. So just remember that 0.4 is really written like 4 times 10 to the -1. So we have -1 minus 8, and we get our -9. All right, everybody up with the notes? Okay, so why don't you try, and then we'll move on from here. What I'd like you to do is do these calculations first by converting the numbers into scientific notation, and then do the calculation.
Excuse me.
Okay, I see most of you at least finished the first one, so we can kind of go on here. first in scientific notation, we make that 6.2 times 10 to the 7th times 2 times 10 to the negative 4th. And so we add the 4 and the negative, or the 7 and the negative 4, and we get 3 for the exponent of the 10. And then we have 6.2 times 2 is 12.4, but that's not the answer because that 12 is not allowed. We need to make it 1.24, and so we adjust the exponent to be 1 more, so we got 1.24 times 10 to the 4th.
Why is the 12 not allowed?
You're supposed to be between 1 and 9. It's supposed to be
right.
one digit in front of the, one non-zero digit in front of the decimal, yes.
So if it doesn't work, then you just have to add one more to your exponent?
Yeah, it's working, it's just not finished. Okay,
Or
so,
like the 12, because the 12 doesn't work, then
Yeah.
we'll reduce it and add one to the...
yes. So think of that 12.4 as 1.24 times 10 to the first, and then we add the 1 to the 3, and we get 4.
And if it's below 1, do we subtract?
Subtract 1 to move it the other direction then. Okay, on the second one, we have 3 times 10 to the 4th times 4 times 10 to the negative 3rd divided by 6 times 10 to the 10 squared. So if you look at the 3 times 4, that's 12 divided by 6 is 2, so that one works out. And then you have the exponents of 4 minus 3 make 1, and then minus 2 from the denominator makes a negative 1, and so you get 2 times 10 to the minus 1.